Hi, I want to talk about Lecture 7, or the material therein. Oh, I bet I can move that so you can see it. Lecture 7, right? Lecture 7 has a whole bunch of different stuff in it. It's all related in that it has to do with where data is in data sets. As always, watching videos is not a substitute for reading a book of notes. Right? You still have to do that. These are more like a supplement to those. All right. First thing I want to talk about is quantiles, right? Quantiles or fractiles, sometimes people call them. That's kind of a generic name for numbers that split a list of ordered numbers, ordered values, into sublists, each having approximately the same number of points. So if you think on a number line, right, and right, we'll just put in some values here. Right? You've seen one of these things before. The median, that's the simplest one of them. The median, you order your numbers from smallest to largest, and then you find the point that's halfway up the list. And it splits this list, the whole list of data, into two sublists. Right? This one has all the stuff that's less than the median. This one has all the stuff that's greater than. Okay. But you can split it into more pieces, right? Now that I have these two, I could split the left-hand list. Right? Well, it doesn't look like I split it in the right place, so I'll just pretend. And I could split the right-hand list so that each of these four little regions here had about the same number of points in it. That's what the quartiles do. Quartiles, right? The first one, Q1, is defined by, about, sometimes it can't be exact, about 1/4 of the data points are less than Q1. For Q2, it's about 1/2 of the data points less than Q2. Oh, that means Q2 is the median, right? That's why I used Q2 to mean the median before. And Q3, about 3/4 of the data points are less than Q3. So in this picture up here, this would be Q1, Q2, Q3. Notice that you only need 3 quartiles to split a list into 4 pieces. You only need 3 split points to get 4 pieces. All right, just like splitting a list into 4 pieces takes 3 split points, 3 quartiles, and the quartiles are the numbers that do the splitting. Percentiles split an ordered list into 100 sublists, right? Each with approximately the same number of data points. For notation for this, we'll use P1 for the first percentile, P2, and so on, right, up to P99. Of course, you only need 99 of those. Notice that, let's go back to the quartiles for 1 second here. Suppose that we really did have a quarter of the data in here and a quarter in here and so on and so forth. And suppose I chose one of these data points at random. What's the probability that the data point I chose would be, say, less than Q1? Well, 25% of the data is less than Q1, so the probability would be 25%. If you painted these red and all the rest green, right, and tossed them in a bag and pulled one out at random, there'd be a 25% chance that you get a red one. Similarly here, right, there is, right, if a data point is selected at random, well then there's a K over 100 chance that it's less than P sub k. So that would say there's a 1 out of 100 chance that it's less than P1, because 1/100th of the data is less than P1. Right? There'd be a 32 over 100 chance, or 32% probability, that the randomly chosen point is less than P sub 32, and so on. Percentiles are usually used only with very large data sets, like SAT scores, for example. Over 1 million people take the SAT every year, and so it's much easier to report percentiles than to actually say how far up a list. You were number 672,322. It's much easier to say, oh, you were in the 67th percentile or whatever. Okay. Let's see. All right. Let's go on to the next item here. The next item is the 5-number summary of a data set. The 5-number summary is very simple. It is the minimum value. I'm going to label it X min here. Right? We're thinking of a numerical data set. This is the minimum value, Q1, Q2, Q3, and then the maximum value. We usually find these, you can find them by hand pretty much, but we really don't find quartiles and so on, and in the 5-number summary in particular by using the calculator. So I'm going to show you this. Suppose, let's see here, do I have this thing printed out? I do. Suppose we're supposed to construct the 5-number summary for this data set. Okay, 2, 3, 3, and so on and so forth. Here's how I would do it with the calculator. This may also be a video in the book, I don't remember. So first thing I want to do is I want to put the data in the calculator. I'm going to do that by putting it in list L1. You get to the lists by pressing the Stat button, and the very first entry is Edit. So that's the one you want, so you don't need to move the highlighting, you just press Enter. And then you type numbers into the list, and the very first list there is list L1. You can see I've already put these numbers in. But to type a number into the list, you just type it. There, I just typed 2 into the list. In fact, I can move around in the list with arrows. I can move over to the next list and move back and so on. I could put 17 in this list just by typing it. And if I type it and hit Enter, it'll go down to the next entry. I'm going to go back up and change it to 2 because that's what's in this data set. And I hit Enter again and it's saved. Actually, you don't need to do much of anything to save. Once you type it in, it's there. All right. Now suppose you have data in list L1. How do you get the 5-number summary? Well, you go to Stat, again, the Stat button, and this time you want to arrow over to the Calc menu. See? The menu in the middle there. And the very first entry on the Calc menu is 1var stats. That's the one you want, so hit Enter. For my calculator, that puts the phrase 1var stats on the screen. In yours, it may bring up a menu or something. Okay, I pressed Enter again to actually execute 1var stats, and I can see a bunch of things there. The very first thing is the sample mean, right, or the mean. The population mean's computed the same way. If I go down a little bit, I can see the sample standard deviation and the population standard deviation, just as the book video shows. And if I arrow down all the way to the bottom, I see the 5-number summary. Minimum, Q1, Q2, the median, Q3, and the maximum. So now I actually have this 5-number summary. I'm just going to go over here and write it down. Here's the 5-number summary. 2, 5.5, 10, 11, 14. That's all there is to it. The next thing to talk about is box plots. And a box plot, sometimes called a box and whisker plot, or sometimes spelt as one word, box plot. A box plot is just a graph of a 5-number summary. It's a particular kind of graph. Usually when we draw them, in class, there will be a number line underneath with various numbers marked on it. And then the box plot itself will look like this. And I'm going to draw it first and then explain what I've drawn. Okay? So maybe it'll look like this. I'll put this out here. All right. And there'll be something drawn in the middle. Okay? It's called a box and whisker plot because it looks like a box with whiskers. All right, what are these points that I've marked out here? This point here is x min, the minimum data point. This is Q1. This is Q2. This is Q3. And out here is the maximum. And then the number line will usually be marked accordingly. So let's construct a box plot for this data set right here. Okay? So I'm going to start out with a number line. And let's see, it has to go from 2 to 14. So mine is actually going to go from, say, 0, well, I'll start at 1, right? And it'll go up to 15, say. So let's see if I can make a decent guess at where things are. All right, so this would be 5 and 10, let's say. All right, the minimum is going to be 2, so that'll be there. And then I'm going to need Q1, which is 5.5, right about there. And then 10, and then 11, and then 14. Those are going to be the points I need for my graph. Here are the whiskers. And then I'm going to draw in the box. Okay. This is Q1, this is 2. I usually want to label these 5.5, 10, 11, 14. That's all there is to drawing a box plot. Okay. Next, we want to talk about the IQR, the interquartile range, which is almost always abbreviated IQR. And all that is Q3 minus Q1. So there's really nothing to it. Right? In that 5-number summary we had just a minute ago, right? Our 5-number summary was 2, 5.5, 10, 11, 14, remember? This is Q1, and this is Q3. So for this data set, the IQR is just, it's always Q3 minus Q1, but I want to note that it is 11 minus 5.5, right? Which is also 5.5, so it happens. The IQR is a measure of dispersion, a measure of variability. Right? The more spread out the data is, the larger the difference will be between the first and third quartiles. Okay, one more little topic in here, and that is the z-score. The z-score of a data point, right, this is for numerical data, the z-score of a data point measures how far that data point is from the mean in units of the standard deviation. The z-score is easy to calculate. I'll give you a formula and an example in a second. It's easy to understand, as a matter of fact. Once you get your arms around it, it's not hard at all to understand. It may be a little difficult to understand why you can measure distance in a data set using the standard deviation. And in fact, that is a very hard thing to prove, that actually makes sense in the way you want it to. We can't do anything like that here. But it does, it works. Okay? So here's the z-score formula. Right? The z-score formula is z, the z-score. Right? Okay, z is going to be the z-score of a data value x. Right? And you compute it using z equals x minus mu over sigma. For a sample, of course, it would be z is x minus x bar over s. In almost all cases, there are two exceptions, and we'll see those later. You should round the z-score to 2 decimal places. That's worth remembering, especially when you're doing web work, homework. Right? It's going to expect that z-scores have been rounded to 2 decimal places. All right, here's an example. A data set has mean 17.5. Right? So let's assume that this is population data. So mu is 17.5. And it has standard deviation 6. So sigma is 6. What is the z-score of the data value 21.2? So the z-score of 21.2 is 21.2 minus the mean, 17.5, all of that divided by the standard deviation, which is 6. And this works out to be about 0.62. Okay? All I've done here is plug in into the formula z equals x minus mu over sigma. All right, I think I've probably said enough for this lecture.